So let's make a start. Good morning to those of you on the West Coast. Good afternoon to those of you on the East Coast. And good evening for anyone who's joining from Europe. And a very warm welcome to you all. Thank you for joining this, the first of what is planned to be a regular series of seminars on pumping topics. This one will last around 30 minutes. We are deliberately steering away from product presentations and towards educational content, addressing a pumping topic in each one. We believe this is very important in the new world order of many engineers working from home, making in-workplace training that much more difficult. Having said that, please forgive me 3 or 4 slides to remind you of who we are and what we do. We are Ruhrpumpen. We are now truly a global company with 70,000 pumping solutions worldwide, manufacturing facilities in 10 countries, over 65 years of experience. Manufacturing plants in 1, 2, 3, 4, 5 continents. And we serve all the industries that you guys are in: oil and gas, chemical, industrial, power, and water. A brief overview of our product lines. We have overhung pumps, foot-mounted or centerline, ANSI, ISO, general purpose, or API-610. Between bearings pumps, axially split, radially split, API-610. Multi-stage pumps, axially split, radially split, double case. Vertical pumps, huge range of multi-stage vertical pumps, API and general purpose, and double case pumps and single case pumps. Positive displacement pumps, mag drive pumps, package systems, and fire systems. Well, that's the end of the commercial. Now back to the subject matter. This seminar is going to look at the key features and the major changes between 12th and 11th editions of API-610. It's not an exhaustive review. Its objective is to support pump professionals who are already familiar with API-610. Ideally, we'd have a Q&A session at the end, but unfortunately, the Zoom type format doesn't make this easy, especially with so many attendees. Say at the last count, there were 130 people on this one alone. We had 200 on the earlier session that I did this morning. So I would encourage you to use the Q&A section at the bottom of your screen to ask any questions or make any comments. We'll address all of them in the coming days. It would really help us to get back to you if you were to include your name, company name, and email address in any Q&A post. We are recording this session and will make it available to anyone who would like a copy. PDF versions of the slideshow are also available. So email us at info@ruhrpumpen.com if you want a copy of one or the other. Lastly, I make no apology for borrowing from others where appropriate, and I give acknowledgement where I've done so. So thank you in particular to Kirit Domadia and Simon Bradshaw. So it's taken, 10 years to move from 11th to 12th editions. And truth be told, there are not many significant changes, which is what you'd expect from a mature standard. Many of the changes are housekeeping and alignment of latest international standards. Here is the first major change. Apologies. They now differentiate between foot-mounted and centerline mounted versions of the axially split case BB1 pump. The foot-mounted version, BB1A, is largely used in cold water service. The centerline version, BB1B, is largely used as an oil pipeline pump. So 11th edition had this 20-year design life, 3 years of uninterrupted operation requirement. This was often misunderstood. It really applied to the structural integrity of the pump, that the pressure casing would be good for 20 years. It did not mean that all components would last for 20 years. Depending on service, you could expect to get through 6 or 7 sets of wear parts in that time, and maybe even 2 or 3 impellers. This is now replaced by API-610 risk-based machinery management. It is a risk-based management system and recognizes that pumps in hazardous, high temperature, high pressure, and/or low specific gravity services are higher risk items and require closer scrutiny at every stage, from feed study through to operation. API-691 expects that only 10 to 20% of pumps will be impacted by this, usually in the classes of critical, unspared, special purpose, prototype, and worst actor. Expect to see more data sheets as part of the specifying and RFQ process. Parallel operation. In my view, the most important change. The requirement that pumps operating in parallel shall be within 3% of each other on the QH curve. I will go into this in more detail later in the presentation. Curve shape and continuously rising curve I will address in a future presentation. This is also a very important subject. Provision for vendor to witness site alignment. This wasn't there before, and it's a clear improvement, especially for hot service pumps and high pressure and complex equipment. Couplings are now specified to be non-lubricated type. Guards have their own clause now. They were lumped in with couplings before, now they have a separate paragraph, a separate clause. This shaft guard is a new concept. It's a requirement now for a guard over the window by the mechanical seal. You note that it must allow visual inspection of the seal without removal, and that it should be constructed of steel, stainless steel, brass, or aluminium materials. I don't see that you can achieve one without the other, quite frankly. Even if you fabricate it from perforated plate, it still seems to me that you can't see the mechanical seal. Perhaps you guys might want to comment on this in the Q&A. More detail is now given on the various types of base plate, and illustrations have been added. So we have the flat deck plate with a sloped gutter drain, that's a drain rim type. The sloped full deck plate, drain pan type, partial deck plate underneath the pump itself, not under the motor, open deck versions, non-grouted versions, and special base plates, gimbal mount, 3-point mount, anti-vibration mount, often used on offshore platforms and for high speed, high complexity equipment. OH2 pumps, or their base plates, must now have nothing mounted alongside the coupling or the bearing housing. So nothing, seal systems must be mounted here or here. No longer can you mount them here or here. They've also removed the 4 smallest base plates from Annex D. I imagine they were seldom, if ever, used. They were 30-inch wide, 760 millimeter wide. These changes, they're no big deal, mainly housekeeping and alignment with the latest international standards. Now we're back to another important one, performance testing. Under 11th edition, we had to test through at these 6 points. Now in 12th edition, they're adding 3 additional points. It's a 9-point performance test, except for very small pumps, less than 11 cubic meters an hour. These 3 additional testing points are likely to have price implication. It's going to take longer to test, and on smaller pumps, so many of these points are going to be almost on top of each other. And again, especially on the smaller end, I question whether a curve drawn through 9 points is going to be any more accurate than one drawn through 6. A well-regarded mathematician, John Neumann, is attributed to have said about curve fitting, with 4 parameters, I can fit an elephant. With 5, I can make him wiggle his trunk. I welcome your comments and thoughts on this in the Q&A. Site performance recommendations. This is a good new requirement, getting the vendor involved in site installation and testing. Probably not necessary on smaller, simpler installations, but critical for more complex pumps. This is significant. Cast iron has been removed from the materials of construction. This will impact mainly utility water pumps, either making them a lot more expensive or having specifiers remove them from API pumps. S5 is now the minimum standard for water service. Again, I'll be interested to see what you people think about this in the Q&A. Data sheets are essentially the same as they were for 11th edition, but we can expect to see API-610 data sheets added for the more difficult pumping applications. Now, as I said at the beginning, this is an overview rather than an in-depth analysis, just the key points that are likely to impact you as a pump specifier. We, of course, have carried out an in-depth clause-by-clause analysis, as I'm sure have all the other API pump suppliers. So here is just one page of this analysis to give you an indication as to the depth to which all manufacturers will be going to ensure compliance. It is, of course, confidential, so I can't share any more of it with you than this. Now I want to look at one thing that API-610 got wrong, and then one thing that they absolutely got right. Here's the clause that I think they got wrong. 6.1.12. Now, I don't think many people will have a problem with this bit. Pumps shall have a preferred operating region of 70 to 120% of BEP. Rated flow shall be within the region of 80 to 110% of the best efficiency flow rate of the pump as furnished. No problem. The purpose of this is to get the pump operation close to BEP. But here's the problem. BEP isn't a single flow rate, but is rather a range of flow rates that varies depending on how much the impeller has been trimmed. Here's an example. Here is your BEP line. Here is your rated flow. So at first glance, to an inexperienced engineer, it looks like an okay compliant selection. Head rise about 122%, 85% of BEP flow, and it's a reasonable efficiency at 76%. So he would be tempted to say, yeah, that's acceptable, that's an okay selection. But he or she would be wrong. I want you to understand the concept of shockless flow. This is the flow rate at which the flow into the impeller impinges on the inlet vanes at the optimum angle. It's normally close to the BEP flow of the full diameter impeller. Trimming the impeller has no impact on the shockless flow. It's a constant. And that's because trimming doesn't impact the flow into the impeller. Onset of suction recirculation is generally around 40 to 60% of the shockless flow rate. So this rated duty point might be at 85% of the BEP flow for the trimmed impeller, but it's at 65% of the shockless flow. This selection is a train wreck waiting to happen. It's probably okay on a small, low energy pump, say a 2-inch or 4-inch, 6 to 8 kilowatts, but definitely not on a 350 kilowatt pump. I would advise you to avoid selections that are close to minimum diameter, or when you have to, select to the right of BEP. For all medium and large pumps, this is. Small pumps, you're still going to be okay, and you'll probably have no choice in many instances than to operate in this sort of operating point. Here's an illustration from Causal of suction recirculation and indeed discharge recirculation. Note that suction recirculation is not impacted by the impeller trim. It's all to do with the inlet geometry. But discharge recirculation is. The more you trim the impeller, the bigger this gap here gets, and the more recirculation you're going to get. So that's what I think they got wrong. Here is something that I think they absolutely got right in the 12th edition. Now, quite a few end user specs had this clause already added into their 11th edition specs, and it's one that I considered important enough to always specify on internal data sheets whenever parallel flow was specified. These parts have unchanged. The pump head curve shall be continuously rising. Head rise from rated point to shuttle should be at least 10%. Those are not new. This is the new part. Head values of the pumps at any given flow within the preferred operating range shall be within 3% of each other. Here is why it's so important, and it has to do with manufacturing tolerances. API allows, and real-world manufacturing requires, manufacturing tolerances. For pump performance, it is plus or minus 3% of the TDH at the rated flow. and a bit more at shutoff. So without this new clause, you could have two supposedly identical pumps, but with a stronger pump and a weaker pump trying to work in parallel, like this. Here you go, one stronger pump at plus 3%, one weaker pump at minus 3% TDH. Here is the combined curve. And here is the rated point. Two pumps operating, one pump operating. Now, your normal operating point could easily be here. Pump A would be contributing this much. Pump B would be contributing this much. So pump B is operating way back at 50% of BEP flow. This is not a good situation for a pump. It's going to wear out in no time. Now, Simon Bradshaw, my source for this slide, considers head rise and even the requirement of a continuously rising curve to be of minor impact on parallel operation. Having matching curves is the key. Now, I agree with him on this, but would add that the steeper a curve is, the more controllable the pump becomes. I will be examining that in more depth in next week's seminar. The impact of curve shape, head rise to shutoff, and zero tolerances on equipment selection, reliability, and pricing. Again, 2 sessions, one for the Eastern Hemisphere and one for the Western Hemisphere. That's you guys. Register now. Future sessions are planned, and I would welcome your input as to subjects you would like us to cover. Again, any comments or questions that you addressed in the online comment section will be answered by us in the coming days. Otherwise, please don't hesitate to contact us by phone or email to your local sales office or to info@ruhrpumpen.com. Our marketing team is standing by to direct your questions or suggestions to the best person to answer them. I will leave this meeting open for a little while to allow you to post in the Q&A or chat boxes. Otherwise, email to info@ruhrpumpen.com. Thank you again for attending today. I enjoyed preparing and presenting it. I hope you found it useful. To help us better understand our audience today, we'll be sending you out a very brief survey. Please do me a favor. Would you be so kind as to complete it and return it to us? Thank you. And see you all next week, I hope.